It's the test button. Oh no.
What's the matter, mate? You look stressed.
Every time I'm testing these RCBOs, there's an RCD upstream keeps tripping.
Oh, it can be a pain, can't it? But there are ways we can get around it now.
I know one, Marcus, and that's to put a limitation on the form.
Yeah, exactly. So one way we can do it is on our EICR, we can note it as a limitation and we can explain in there that we couldn't test it for that reason. We could also argue the case we could code it accordingly because there's no selectivity between devices. But we also have to look at it where we may not have installed these. It could be an EICR, we could have added an addition to this board, etc. And there are other ways we can overcome it. Another way is we could swap that RCBO out for an MCB, let's say, perform the test, swap it back. It might be that they've put that RCBO there for additional protection because how the cable's been run, etc. But I've got a sneaky trick, which I'm about to show you and the world, on how we can test our way around that. And actually, if we perform this test at the start without knowing, it could get us out of trouble.
I'm really interested to learn about it. Come on, Marcus, show me.
We would generally have a lead go into our MET, wouldn't we? Which we've got there in the footage. But then if we have an RCBO, we'll maybe probe onto the top of the RCBO or an RCD on the relevant terminations. But what we're actually going to do now, we're going to take our lead that is connected to our MET or our earth bar. And what I want you to do, I want you to put that on the incoming neutral bar. So once that's on there, what I want you to do now is test the RCBO as you normally would. So you're going to probe onto the line and the neutral on the top of the RCBO. Bear in mind, we still have an RCBO upstream of this. And if we operate the test button, we're testing it at times one its value.
30 milliamps, Marcus.
30 milliamps, good.
28.0
milliseconds. So now, just to prove that it hasn't tripped the upstream RCD, I just want you to turn that back on. And now I want you to test it at 180 degrees just to prove that the power has stayed on from the upstream RCBO. So we go on the top of the RCBO and then we perform the test again.
So Marcus, I didn't change my meter in any way, set up as I normally do on auto. But how does that all work then?
It's quite clever, isn't it? So if we look at how we normally test an RCBO now, we would go onto the MET or the earth bar. Remember how an RCD works, or an RCBO, the internals of it, is we have an iron core is connected to line and neutral. And what that does is that monitors a balance between the magnetic fields produced by line and neutral. So hence, if we have 10 amps coming down the line, we need 10 amps coming back through the neutral. If 10 amps goes down the line and 1 amp comes back through the neutral, then we know that current is going somewhere. If it's not come back through the neutral, it must be going to earth. Hence, it picks up that as an earth fault via an imbalance. So when we're testing this RCBO, we're trying to detect an imbalance or create an imbalance in here to cause it to trip in the correct time. However, because we have an RCD upstream, that is also seeing the imbalance. So that is tripping as well. So what we need to do is when we go onto this neutral bar, rather than the tester diverting 30 milliamps down to earth, what we're actually doing now is we're diverting that 30 milliamps down the incoming neutral from that RCD. So now the RCD upstream is not seeing that imbalance between line and neutral because a certain amount of current goes through the line, but because we've diverted the current back through the neutral, that is seeing the exact same amount of current come back through the neutral. However, our RCBO in question here is still seeing that imbalance because it's being diverted down a different neutral path.
So it's like if ever you try and put an RCB on a split load board on the opposite neutral bar, you can't reset it because of course. It sees that imbalance.
And effectively all we're doing is we're just diverting that current down the incoming neutral, which is balancing the RCD upstream. So a massive time saver in terms of being able to test devices. We could still again argue we could code selectivity, etc., but we can still ensure that these devices are going to work in the correct times and parameters that they're set to in the regs.
And that's just fantastic because now not only am I going to save me leg work, I'm saving, I've not got to fill in, I can do proper tests. I'm not going to put selectivity or code it as a C3.
100%.
And I am actually testing this device. Is what I'm here for. Does that trip in the
correct times? And it might be that you've made an addition to this board. So it might be you're not actually fully aware, you're not used to the installation, you're not fully aware of what's going in other distribution boards. So as a safety measure, let's say you're in a big warehouse, you don't want to kill the power to a certain area without telling anyone. It might be that you test the RCBO in this way so that you don't trip it and cause unwanted tripping and maybe a dangerous situation if someone's working with a particular piece of equipment. So we can do this to test them and then investigate afterwards.
Thanks for that, mate. Saved me loads of times.